This is Digit. Digit is designed to work in human spaces, to work around people, in environments that are easy for people to navigate and to work in, but typically are not accessible to robots. We're really excited to announce we've just closed a $20 million investment round, led by DCVC and Playground Global, among others, to build a really excellent consortium of investors. And that's going to let us really get our Digit robots into customers' hands, doing useful work in the world. Industrial robots are designed to do one task over and over and over, and to do it well, you design the whole process around the robot and the whole environment around the robot. But there's always going to be spaces and jobs that are designed around humans, designed around us, because this is our world. If robots are going to be effective and useful to us, they're going to have to work on our terms in our space. Having Digit work in human spaces means Digit is going to be able to do a wide variety of different tasks. Things like package handling in warehouses, or indoor and outdoor delivery, or inspecting hazardous workplaces, or any application that requires the basic abilities and shape of a person. We're producing Digit now, and we're delivering Digit to customers. We're building on 15 years of our own research work. We're also building on a whole community's worth of work, studying biomechanics of how animals move, and studying the basic physics of how do we make robots move that way. To get Digit to operate in our spaces, these robots need to not necessarily look like us, but they need to move like us. At Agility Robotics, we made our first robot, Cassie. Cassie was just a pair of legs. It was very useful for us to build a culture of building products and supporting products for customers. And we got them out there to some of the top universities in the world. Now with Digit, we add perception, we add path planning, we add awareness of the world around us. We add arms. This whole body behavior is really a hallmark of the human capability, and now robot capability as well. This technology just didn't exist in a way that could be implemented a small number of years ago, and it's going to change things. With the automobile, we had to build roads. With legged robots, we've already built the infrastructure. Legged robots are going to change the world as much as the automobile did. Robots that are our form factor, live in our spaces. Now that we have the technology and know how to do that, now that they're starting to be useful, it's going to grow, it's going to grow, it's going to grow. And you're going to see robots delivering packages back in warehouses, doing the backroom work, and getting to be more and more useful and helpful in our lives. This version of Digit is ready to go. It's ready to go to our customers and start doing useful work, and that's what this investment is going to let us do.
It's running.
Joel, I want to introduce you to Trixsy. Trixsy is a card magic robot. It's a card finding robot. So Trixsy is a very simple robot. So I take a deck of cards here, and your job is now to help me with this trick by taking a card, and then we're going to show it to Trixsy so Trixsy can learn it, and then Trixsy will try to find it again. So take a card.
Okay.
Or this one. Okay, wait. Now look at that card. Look at that card. Show it to the camera. Okay. Now.
That's a good card.
Now show it. Now show it to Trixsy. Trixsy, and Trixsy doesn't know it yet. Come back here a bit, Trixsy. Oh yeah, Trixsy likes that card. Okay, Trixsy has now learned that card.
Okay.
Now take that card and put it back anywhere in the deck. Now you shuffle the cards. You're not really a card player, are you?
No.
Okay, that's the kind of subject I like.
Does it make it easier for Trixsy? Or?
Okay, that's good enough. You're happy that the cards are mixed?
Yeah,
it doesn't matter.
Yeah, okay.
Your
happy.
card, your hidden secret card, which only Trixsy knows, and you guys, has to be found. Now let's see. Let me ask you now. If I look through the cards like this, can you see your card anywhere?
I saw it. Yeah.
You saw it?
I saw it. Yeah.
I mean, it's somewhere in here, right?
Yeah, yeah. But I saw it.
I don't know where it is.
Yeah.
Somewhere.
Yeah.
Okay. So now, here's what you do. As the cards go by, stick your finger in exactly at your card. Ready? Hold your finger out like this.
Okay.
Ready? 1, 2, 3. Come on, man.
really difficult,
Just stick your finger in there.
No, I can't do it.
Okay, let's see if what Trixsy can do. Okay, are you ready, Trixsy? Are you ready, Trixsy? Damn it. Yeah.
Yeah.
Trixsy stops exactly at this card.
Yeah,
Is
that's
that
the
your
card.
card?
Yes. Let's show it to the camera. That's my card. Yeah. Trixsy is better than me.
Anywhere you like. Just
Okay.
as I go through the cards here.
Yeah.
Okay, right there. Okay. Trixsy doesn't know exactly where it is yet, but watch. Does Trixsy do it? Trixsy did it again.
Yeah.
You hear this DVS? Trixsy uses this Davis 346. The frames are assembled at constant count, 3,000 events per frame. And then here you can see the frames coming in. They're subsampled down to 224 square. That's the input to the CNN. And then the CNN runs on the GPU, this GTX 980, running a TensorFlow Lite in about 2 or 3 milliseconds, maybe about 3 or 4 milliseconds. And then the command comes out over USB to this Arduino. The Arduino turns on a bit, which turns on this first bipolar transistor, which turns on the gate of this power MOSFET to about 20 volts. That dumps the current stored on this 11 farad ultra cap array, which holds about a kilojoule, onto this solenoid, which then makes the finger go out as fast as possible. And the latency to go from the computer to this finger going all the way out is about 10 milliseconds. So total, you have about 15 milliseconds of processing to get to the card, and the card is going by 1001, about a second, so you got about 20 milliseconds of card.
Gazı kes.